All right, guys, Mr. Antonucci, and we're back here, and now we're ready to put everything together. And in this video, I'm going to show you how to do a two-sample t-test for a difference in sample means or difference in means from two different samples. So this is called a two-sample t-test for a difference in means. Again, another significance test of the null hypothesis that the difference in means of two populations or two treatments is equal to a specified value. Typically, we're going to look at when it's zero, when both population standard deviations are unknown. So let's take a peek at an example here. Does increasing the amount of calcium in an adult's diet reduce blood pressure? Researchers designed a randomized experiment to find out. The subjects were 21 healthy adults who volunteered to take part in the experiment. They were randomly assigned into two groups. 10 of the subjects received a calcium supplement, while the control group of 11 subjects received a placebo pill that looked identical to the calcium supplement. The experiment was double-blind, meaning neither the subjects nor the ones administering knew which supplement they were getting, whether they were getting the supplement or the placebo. So the response variable is the decrease in systolic top number, blood pressure for a subject after 12 weeks in millimeters of mercury. An increase appears as a negative number, and we have the data here. So we want to answer the question, do these data provide convincing evidence that a calcium supplement reduces blood pressure more than a placebo on average for healthy adults like the ones in this study? So here we go. First thing we got to do, we have to follow the four-step process. And the first thing is state our hypothesis and define our parameters of interest and declare the significance level. So the null is that the mean difference is zero, and the alternative is it's greater than zero. So notice here, the alternative is one-sided because researchers want to know if the calcium supplement reduced blood pressure more than the placebo on average. All right. Hmm. So in the plan step, we have to check the um, conditions, but I know we're talking about two sample t-tests for difference in means in this video, but in general, when you're doing the four-step process, you have to state what procedure you're checking the conditions for before you start checking them. So again, we're going to do the normal. The 10% actually doesn't apply because the subjects in the experiment were not sampled without replacement from some larger population. Okay. So the 10% condition doesn't apply. So random, the 21 subjects were randomly assigned to the calcium or placebo treatment. Normal, large sample, the sample sizes are small. They're both less than 10. But if we look at a dot plot, they don't show any strong skewness or outliers. So again, remember, if your sample is small and you don't know the population distribution, you have to produce a graph. A dot plot will do, but make sure you label it correctly and put an axis and some scaling in there. Okay. Now, the next step we want to do is the do step. And this is where you list the statistics and calculations. So we have our mean for the calcium sample, the standard deviation, and the sample size, and the same thing for the placebo. Okay. Then from that, we can calculate the t value, which is 1.604. Now, we have a graph here of the t distribution and the part shaded, since it's a one-sided test and it's a greater than, we're looking for the probability of getting this result or larger. In the p-value using technology that I showed you in the calculator example previously, for a t-score or a t-value of 1.604 is 0.0644. That's not negative right there. You can't have a negative p-value. So with degrees of freedom, 15.59. Again, you can do all of these calculations on the calculator, but make sure you write them down on your paper. Don't just, for the whole do step, don't just write p-value equals 0.0644. Okay, make sure you put the summary statistics, the t-value, and the degrees of freedom as well. Okay, last thing is our conclusion. Because the p-value of 0.0644 is greater than our significance level, we fail to reject the null. This experiment does not provide convincing evidence that the calcium supplement reduces blood pressure more than a placebo on average for healthy adults like the ones in this study. Okie doke. Now, the second thing we're asked to do is interpret the p-value that we got in the previous part. So the p-value, always start out, it's going to be a long sentence in context, referring back to assuming the null is true, using the p-value and the statistics you got from the sample or the experiment. So assuming that the mean difference is 0 is true, there's a 0.0644 probability of getting a difference, calcium minus placebo. It's important to specify the direction that you're calculating the difference in mean blood pressure reduction for the two groups of 5.273 or greater just by chance, just by the chance involved in random assignment. Okay, so that's how you would interpret it. And then last question we have here is why didn't researchers find a significant difference in the blood pressure when the calcium supplements were taken? So if you think about it, the mean difference, if we look at our mean here, if you did 5 minus 0.27 minus negative 0.273, you would get a sample mean difference of 5.273, which seems like a relatively large amount. So while that does seem like a fairly large difference, because we had small group sizes of only 10 and 11, that difference wasn't large enough to provide convincing evidence in favor of the alternative hypothesis. Now, if you did a larger group, it might show a similar difference in mean blood pressure reduction, then that would probably indicate that calcium has a significant effect. So if you have larger groups, but we would end if we ended up with the same sample mean difference, it might show to be a statistically significant result. If that is actually the case, then the researchers in the experiment made a type 2 error. They did not find convincing evidence for the alternative when it's actually true. Okie doke. So with that, we will wrap it up with this video. Hope that was helpful to you. Reach out if you have any questions. Take care.